Now we're going to determine whether a series is convergent or divergent. Our series is 1/5 plus 1/7 plus 1/9 plus 1/11 plus 1/13 and so on, so plus dot dot dot. We note that all the numerators are 1 and the denominators 5, 7, 9, 11, 13 form an arithmetic sequence. As you may recall, the nth term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times the common difference. Here, the first term, a sub 1, is equal to 5, just looking at the denominators. And the common difference, well, the denominators are increasing by 2, so the common difference is 2. Therefore, for the denominators, we have that a sub n is equal to 5 plus n minus 1 times 2. Simplifying gives us that a sub n is equal to 2n plus 3. This allows us to write the nth term of the series, which I'll do using sigma notation. We're looking at the sum as n goes from 1 to infinity of 1 over 2n plus 3. Now we have the sense that this is probably going to have a limit of 0, but let's go ahead and write it down. And what I'm applying right now is the test for divergence. The limit as n approaches infinity of 1 over 2n plus 3 is, oh look, it's 0. The test for divergence didn't work out. That means we have to keep working. Applying the integral test, we're going to take the integral from 1 to infinity, and I'm using the same lower limit as I have as the index. And the integral is from 1 to infinity of 1 over 2x plus 3 dx. It is important that we don't write down n's in integrals because the n represents a bunch of discrete points. Right, a bunch of discrete values, whereas here I've written down a continuous function of x, and most of what we have written down in the past about integrals involves continuous functions. What we are looking at, though, is an improper integral. It has an upper limit that's infinity, so the first thing we need to do is write it down as the limit as t approaches infinity of the integral from 1 to t of 1 over 2x plus 3 dx. Now, recognizing that I have a composition, a reciprocal function with an argument of 2x plus 3 that's in the denominator, I'm thinking about a substitution. U is equal to 2x plus 3, which implies that du is equal to 2 dx, excuse me there. So I'm going to take this integral, the limit as t approaches infinity of the integral from 1 to t, I'm going to multiply and divide by 2 so that I have a du in the numerator. Kind of. Really, the du is 2 dx, isn't it? So we have the integral, the limit as t approaches infinity of 1/2 of the integral from 1 to t of 2 over 2x plus 3 dx. Since I have du over u, this is going to integrate using a natural log. We have 1/2 times the limit as t approaches infinity of the natural log of 2x plus 3 evaluated from 1 to t. Notice I didn't use absolute values around the 2x plus 3 because all the numbers that we're going to put in will result in a positive argument anyway. Well, if I put t in place of x, and then take a limit as t approaches infinity, what we have is the limit as, well, 1/2 out front, right? Times the limit as t approaches infinity of the natural log of 2t plus 3 minus the natural log of 3 from plugging in 1, the lower limit. But what I was starting to say, and then I had to realize I had to do the math, is that if I plug infinity into t, the natural log is going to go to infinity. Therefore, this integral has, it evaluates to infinity. And since the integral is divergent, the sum 1/5 plus 1/7 plus 1/9 plus 1/11 plus 1/13 plus dot 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 diverges. I'm going to write down by the integral test. Even though there's no way we could have used really any other test because the test of divergence failed, but this is going to be the format of how you're going to give your answers throughout the chapter. You're going to have multiple tests that you're going to reference. And so you're going to be asked Does it converge or diverge? And by the way, what test did you use?